Hello and welcome to the video notes for the rest of Chapter 9, Lesson 2. We will be talking about regular polygons today, and our objective will be to be able to develop and use the formula for the area of a regular polygon and to use that formula to solve problems. So let's take a look at this. In class we mentioned that the area of a regular polygon can be found using this formula. Remember that a regular polygon has congruent sides and congruent angles. The area of a regular polygon then is 1/2 apothem times perimeter, or apothem times perimeter all over 2. It could also be written this way: apothem times perimeter all over 2. So we can use this formula, but we have to know what these words mean. Perimeter is just the sum of the side lengths, but the word apothem refers to this segment here connecting what we call the center of the polygon to a side at that side's midpoint. So let's take a look at these terms. The center of a polygon is equidistant from the vertices, and we talk about the center of regular polygons. The apothem is the distance from the center to a side, and a central angle of a regular polygon has its vertex at the center, and its sides pass through consecutive vertices. Each central angle measure of a regular n-sided polygon is 360 divided by n, which n is the number of sides. We just take 360 divided by how many sides there are. That tells you the measure of the central angle. So in this example I've given you here, we have a regular pentagon, DEFGH. It has its center at point C. The apothem would be the length of BC, that perpendicular segment from this side to the center. And a central angle, we could call the central angle DCE. That central angle would be the same measure as DCH, HCG, GCF, and FCE. Those are all central angles. To find the measure of a central angle of a regular pentagon, we would do this. We're going to take 360 degrees and divide it by 5. In doing so, we realize that the central angle is 72 degrees. That means the measure of our central angle, DCE, is 72 degrees. So let's take a look at our example 3. Once again, we're going to start with this formula. The area of a regular polygon is apothem times perimeter divided by 2, or you could say 1/2 apothem times perimeter. Either way you write that is okay. And we're going to use that to find some measurements here. Now, in example 3a, we are given a polygon with 1, 2, 3, 4, 5, 6 sides. That makes it a hexagon. We need to know the apothem and the perimeter. They give you the side length of this hexagon. Well, if there are 6 sides, each measuring 12, 6 times 12 is 72. So we know the perimeter, 6 times 12, equals 72. And if we know the perimeter is 72, all we need to know now is the apothem, because remember we're using this formula. Area equals 1/2 apothem times perimeter. So I just need to know the apothem, then I can tell you what the area is. But here's how we have to find that. To find this measurement, we are going to set up a triangle formed by the central angle and the apothem. And I say that because we're not actually going to use the entire central angle. We're going to use half of it. We're going to cut this triangle in half. So the central angle here is going to be cut in half, and I'll remove that in just a minute. So we need to figure out how to find that central angle. Remember, to find a central angle, we take 360 and divide it by the number of sides. Well, this is a hexagon. It has 6 sides. So 360 divided by 6 is 60. That means the central angle measures 60 degrees. What we're going to take half of that. We're going to take half of that. Let me get rid of this line. And so half of a central angle, that angle measure, would be 30 degrees, because I only want half of that triangle. So we're going to measure that as a 30-degree angle there, and this is a right angle here. Well, you might remember this is a 30, 60, 90 triangle. Even if you don't, we can still use our trigonometry, sine, cosine, or tangent, to help find what the apothem is. So let's take a look at how to do that. We have our 30-degree angle here. We actually know this leg of this small right triangle we've made. What you should recognize, this leg is half the side length of the hexagon. Well, the side length is 12. That can tell you that this leg right here is 6, because this would be 6 and this would be 6. The apothem always bisects a side length. So I know this side of the triangle is 6. I am looking for this side. These are both the legs. The 30-degree angle here is going to be used. So if you remember back to our trigonometry, we talked about SO, CA, TOA in Chapter 8. Well, sine of an angle measure is opposite leg over hypotenuse. Cosine of an angle measurement is adjacent leg over hypotenuse. Tangent of an angle measure is opposite leg over adjacent leg. Since I'm using the opposite leg to find the adjacent leg, I need to use tangent. And so to find the apothem, we're going to say that the tangent of our 30-degree angle is the opposite leg 6 over the adjacent leg apothem. And we're going to solve this equation. Now, one thing we can do to set this up, make it a little bit easier, is think of this as a proportion. We're going to put tangent of 30 over 1. Well, tangent of 30 over 1 would have to equal 6 over a. That's a proportion. To solve our proportion, we're going to cross multiply. 6 times 1 is 6. Tangent of 30 degrees times apothem is apothem times tangent of 30 degrees. Then we divide both sides by the tangent of 30 degrees. Okay, so with our calculator, we're going to evaluate that to use as our apothem. We're going to divide 6 by the tangent of 30 degrees. Make sure that your calculator is set to degrees. In doing so, we get that our apothem then, A, is about 10.39. So we're going to use that to write down here. We're going to say that the apothem is about 10.39. But then whenever we plug that part into our calculator, we're going to use the exact value from the calculator. You should have something like 10.39230485. We're going to use that value saved in our calculator screen. And we're going to multiply 1/2 times that apothem, 10.39 and so forth, times the perimeter of 72. So all we have to do with our calculator is take that value that's already there, hit times 72, and then divide by 2. In doing so, we should get that our area is about 374.12. Sorry, they want it to the nearest tenth, so we're just going to make that 0.1. 374.1 square units. And we aren't given a unit of measure here, so let's just write square units. The word units squared. All right, let's try that again for part B. We're going to deal with a hexagon again, and in this case, they give us a little bit of different information. In this problem, they give us that the apothem is 12 root 3. We're going to use that apothem to work backwards and find the side length so we can find the perimeter. We're still going to use the same formula that we have 1/2 of our apothem times perimeter. But those are the two measurements that I need. And they do tell me to write this in simplest radical form, so that's going to come into play here in just a minute. So here's how we need to do this. We're going to take a look at the given apothem. We're still going to use half of our central angle again. I've still got a hexagon, so our central angle is still 360 divided by 6, or 60 degrees. So I want to use half of that and work with this right triangle. So we have another 30-degree angle there. Half of the central angle makes that 30 degrees. So we've got a 30-degree angle here, a 90-degree angle here. That makes this a 60-degree angle. This is why I mentioned we could use special right triangles, because we have a 30, 60, 90. Well, we're given the apothem of 12 root 3 as the longer leg. If you'll remember, the longer leg of a 30, 60, 90 triangle is the shorter leg times root 3. Well, if this is 12 root 3, the shorter leg must be 12. Remember, the shorter leg of this 30, 60, 90 triangle is half of a side length. This should tell you that a full side length is 12 plus 12, or 24 units long. So I know my perimeter is the side length of 24 times 6 sides. If I do 6 times 24, I get 144 for my perimeter. So I know the perimeter is 144. I'm given the apothem of 12 root 3. And I can write in my equation now that my area is 1/2 of that 12 root 3 times my perimeter of 144. And now we need to simplify this. You can do half of the 12 or half of the 144, then multiply by root 3, and the other of the 144 or 12 that you didn't use. So either way, in terms of root 3, what we should get for our area is 864 root 3 square units. All right, we'll do a little bit more examples in class, but I do want to finish out one or two more things with this video. When we are given a regular polygon, we're going to be given one of two different things. Either we're going to be given the apothem and need to find the perimeter like we just did in example 3b, or we're going to be given the side length and have to construct our apothem using half of a central angle. Remember, 360 over n, and we're going to divide that by 2. So we're going to do some more examples with this, but remember, n is the number of sides, s is the side length of your regular polygon, a is the apothem, and p is the perimeter. So we'll do a few more examples in class together. There was part of the examples in the note packet that did not get covered, the part that comes right above example 3. We will do that in class together and get a lot more practice at finding the area of a regular polygon.